So the last session we discussed IGMP version 1 and IGMP version 2, right? So today IGMP version 3. Okay, IGMP version 3. See, IGMP version 3 adds one more major feature in IGMP version 3. This feature was not present in version 1 or version 2. The major feature is source specific multicast. Because version 1 and version 2, it was any source multicast. Any source, see version 3 can support SSM, source specific multicast, as well as ASM. But see version 1 and version 2 support only any source multicast. If your receiver would like to receive or would like to address any source specific information, it is not possible in version 1 and version 2. But version 3, it has this feature. But here, see, version 3 introduced new MAC address 0.0. See, this is new MAC address. And backward compatibility is there because when version 2 was introduced, it had backward compatibility to interoperate with version 1, and version 3 has interoperability to operate with version 1 as well as version 2. So backward compatibility is there. Okay, and layer 3 destination IP address 224.0.0.12. Okay, so now this packet structure is very complex. Version 3 is very complex protocol because the structure itself is very complex. I explained version 1 and version 2. See, the packet format or packet content. It was very straightforward contents, right? Type, version type, then maximum response time, then group address, checksum. See, very limited fields. 4 to 5 fields are there in version 1 and version 2. But version 3, the format itself very complex. See, let me just draw it. See, as usual, one is type. Then reserved. See, we have few fields. Those are actually reserved. Means for future purpose. Then as usual, checksum, for error detection, right? Then again, we have few more is reserved. See, reserved field we have. See, then we have number of group records. See, this message can carry multiple group information. See, number of group records means if you have 2 groups. See, here number of groups, 2 group. If you have 3 groups. See, number of group records. Have you seen this field in version 1 or version 2? No. Number of group records field is not there. Means IGMP version 1, version 2, if you have 2 groups, you need to generate or create 2 separate version 1 and version 2 messages. But here you have the same message itself, you can carry multiple group records. See the difference. See? Now, here, let me change color. See, these are group records. See, if you have multiple group records, you can have multiple group records. See, like this. Group records. Okay, this group record is entirely different content or fields are there. See, the core field of record type. Record type is one of the crucial fields in IP version 3. Okay, version 3. See, crucial field. Actually, this record type, it is present inside the group records. Inside the group records. If you have three group records, there are three different record type. I mean, this is the explanation, or elaborate. I'm just elaborating this field. Group address, group records. So inside group records, I have these fields. One is group. This is okay. This is crucial, and this one is not. These are some auxiliary data length is there. This is actually 0 always. Then see number of source. See number of source. See, you can specify multiple source as well. See, group records means you have multiple groups. So each groups can carry multiple sources as well. So this is number of source. See, your multicast group. Multicast address or group. See, here you have source address. Here you have source address. See, this is your format. Same format here, same format here. If you have multiple group records, if you have one group record or one group, yes, then only one. If you have two, then two. Depends. See, if you compare to version 1 and version 2, these fields are very complex. Version 1 and version 2, their fields were very simple. Only type, version, then checksum, then group address. Then this one, maximum response time in version 2. In version 1, it was unused to this. It was very straightforward. But see, this here, this record type is very complex concept. The same record type is used to differentiate your messages. See, this group record, let's assume this is any source multicast. This is not source specific multicast. See, I'm joining this particular group, but I don't care about source. This is source, any source multicast. See, I need to differentiate this message from source specific multicast. See, I can use it. Here I am using SSM. See, so here in this record field, I'm using something else that was not used in ASM. In ASM, I used something else which is used to indicate ASM. But here in SSM, in this record type, I use something else which is used to indicate SSM. And if you leave, right? If you leave the group, see, again, key role is record type. Record type. Here there is no separate IGMP leave message. See, the same format, but we play with record type. The record type is, this is one backbone or crucial fields in IGMP version 3. Any question? Let me expand this record type next. So before that, do you have any question from your side so far?
No, sir, all good.
Okay, fine. So now record type. See, first of all, it did not exist in version 1 and version 2, right? It did not exist in version 1 and version 2. So record type is how the host reports that decision. Decision means, say, ASM or SSM or leave. So we need to differentiate, right? So by leveraging record type field, Version 3 can support any source multicast also. See, so if you have network, if you need to configure ASM as well as SSM, then preferred method is version 3. If you configure version 1 or version 2, these two methods don't support SSM, but they can support ASM. It's very, flexible format. It's very flexible format, this version 2, because you have record time. Okay. Now, let me record time. See, I have two record type. Please pay attention here. It's quite complex, this part. Record type. See, one is mode is include. Include is actually default mode plus it indicates SSM, source specific multicast. Don't get confused with SSM concept. SSM means I'm specifying source. I would like to receive multicast stream from this particular source, not any source. I need multicast stream from this specific source itself. If source is different, I'm not interested. Okay. So this is include. This is include mode. Then next one is mode is exclude. Mode is exclude. This is not default mode. See, mode is exclude. So this is generally we use along with ASM. Exclude mode. See, include means you are including something. That something is source specific. That something is source specific. You are including something. Here we are not including anything. Right? Exclude means now record type. See, now filter mode change. Filter mode change. Okay. Change to include mode. I will let me explain these concepts in the next session. You will get better understanding. Change to include mode. Then one more filter mode is change to exclude mode. See, one of the group was operating in SSM state, and if you configure SSM state when it was operating in SSM state, it was include mode. So when you change it from SSM to ASM, any source multicast, see, change from include to exclude mode. When one of the group is operating in any source multicast mode, and if you are supposed to change it from ASM to SSM, see, change to include mode. See, earlier it was exclude, now it is becoming include mode. See, concepts. Now, source list change. See, it is used when source of group changes. Okay, source list change when sources of a group changes. See, currently we are using group plus I would like to receive from 1.1.1.1. See, I'm changing my source. I'm changing my source. Currently, it's from 1.1.1. I'm changing from 1.1.1 to 2.2.2. See, source list change. See, now what happens? Allow new sources. Allow new sources. Means currently 1.1.1, I'm changing to 2.2.2. See, allow new source. Allow new source. Then I'm leaving the group. If you are leaving the group, use block old source. See, there is no different message. The same message, record type, see, record type, block old source. This is equal to group leave message in IP version, sorry, in IGMP version 2. Okay. Now let me come to first scenario. See, receiver join a new receiver joins new ASM. Any source multicast. See, any source multicast. What happens? See, now which field is relevant? This field is relevant. Why? IGMP version 3 default mode is include, but I am joining any source multicast. So this mode is relevant here. Change to exclude mode. See, change to exclude mode. Now router knows. See, IGMP, the communication happens between source, between end devices and router. Right? When router receives this packet, router knows change to exclude mode. Yes, this receiver would like to receive any cast for any source multicast. Right? Second one. Second scenario. Then leaving this group, right? Receiver leaves ASM group. Now what happens? See, now change to include mode. See, now you might be surprised why change to include mode. Change to include mode with number of sources 0. See, change to include mode plus number of sources 0 means leaving the group. There is no source group. See, if it is include mode, you need number of sources, right? But here number of sources 0 means it is not actually join message, or it's not report message. If it is report message, there would be number of sources at least minimum 1. But here it is not there, right? Next, receiver join new SSM group. It's not ASM, it's SSM, right? Now it comes here. Allow new source. Allow new source. Why there is no include include field? See, include is default. Then why should I again explicitly define it? Not required. So device knows allow new sources. See, it's SSM and allow this source. Is it leave message? No, it's not leave message. Allow new sources. It's not leave message. Then receiver leaves an SSM group. See, now this field comes to here because I'm leaving this group. I'm no more interested to receive multicast streams from this source. See, SSM leave mechanism. Here I used this one. Okay, so this is default mode. This is ASM exclude means it's not default mode, right? So I used this mode here along with ASM. When leave message goes, see, I'm changing my mode from exclude to include, but I'm notifying number of sources 0. Means router knows, okay, this is leave message because number of sources 0. SSM joins, see, I'm using, see, here this mode specification is not required. It's a default mode is include, means it's a SSM message, so include mode. So allow new sources. Then block, see, leave message, block old sources. Means I'm leaving this group. I'm no more interested to receive multicast streams from this group. And also here you have, as usual, group specific query, right? You know, right? Yesterday I explained group specific query. See, if one of the receivers send leave message, means in this case block old sources, because router needs to confirm is there, I mean, any other sources or any other receivers are interested in this group. If router stops incorrectly forwarding multicast streams, it is going to impact those live users. Those live users, right? It should not happen. It should not happen. So router need to make sure I'm not doing incorrect behavior. Incorrect behavior means if they stop forwarding multicast streaming, it's incorrect behavior. To protect themselves, what they do, they send group specific query. Is anyone interested in this group? Because I have already received a leave message from one guy. Is anyone else? Yes, we all are interested. Remaining hosts send interested message. So router doesn't stop. If there is no response, router assumes, okay, no one is interested. So I'm going to stop sending multicast stream. So in the last session, I explained this one as well, right? So the same group specific query is present here. So this is your LAN L3 protocol. See, it works in LAN network, but it is L3 protocol because I'm at to start L2 protocol. See, this is L3. 1 minute. Okay. So, see, your network, you have, see, many users, you have switch, behind switch, devices are there. It might be big LAN network, right? Like this something. Okay. See, this communication, IGMP communication is between these two devices. These two devices. See, but physical path, physical path is through switches. How does switches react to IGMP messages? As usual, flooding. As usual, flooding means the question is saying how does switches react to bump traffic? See, in L2 VPN or EVPN session, I covered bump traffic, right? Bump means broadcast, U means unknown unicast, M means multicast. So how does switch react to multicast traffic, unknown unicast traffic, multicast traffic? Result or answer is flooding. Answer is flooding. See, it doesn't read or it doesn't process or it processes actually the learn source MAC address, and based on destination MAC address, switches flood the frame throughout VLAN. Throughout VLAN. So here the problem is, so why should I start now L2 protocol? Let me explain the problem if there is no L2 protocol. See, this is my router or anyway, source, something. I'm just using a single device. Here I have device 1, device 2, device 3, device 4. These all are belong to the same VLAN. Assume VLAN 100. Okay, any VLAN. Okay, I'm checking VLAN 100 for reference. Here some interested parties are there. So interested parties are interested, interested, not interested, not interested, right? Because here some users are watching Star Sports or something, some TV video or some your official, meetings. It's over. Anyway, here users launched their multicast application here and here, right? Here and here, these users are yet to report in the office, report at the office, or they haven't opened their, launched their multicast application. Anyway, these two devices are not mixed. I'm receiving almost 1.5 Mbps traffic multicast. See, switch. This is ingress interface. What switch does? Switch floods except the ingress interface. So except this interface throughout the same VLAN. See, I'm expecting, okay. See, I'm also expecting because I'm interested in this group. See, here also, I have never expected 1.5 GB traffic or 1.5 MB traffic. 1.5 MB traffic on this link, and I'm gonna process or I'm getting it. I never expected this traffic. Same thing here as well. I have never expected this 1.5 MB traffic. But switch behave in their classic way or in their legacy way, because switch doesn't know. Because what happens switch? How does switches react to bump traffic? Answer is flooding. See, bump multicast. Switch flooded throughout the VLAN. So received 3 and 4 as well, but they have never expected this multicast stream. But I need to protect this unwanted flooding. I want to protect my network from this unwanted flooding. My layer 2 network, not layer 3, not layer 3. See, layer 3 means here communication between these two devices. IGN. Now, next, I'm gonna start layer 2 protocol. See, it operates in suits because I need to protect my network from this unwanted flooding. You know, right? See, one of the easiest example for multicast streaming IPTV, right? How it works? IPTV means you have IPTV server. Means this is IPTV server is head end or this is your source. From here, streams are coming, right? You have internet, so it might be in Airtel or Jio or any other provider, okay, in India, right? Even BSNL provides, right, IPTV service. See, the IPTV, see, backend IPTV, it might be satellite or fiber. It's not in our control, right? It's entirely different or beyond our scope. Okay, anyway, channels are coming here, IPTV. You have internet services in your home. Although your neighbor, you all are using IPTV services. See, your TV might be smart TV, or you might have, if it is smart TV, oh, yeah, of course, you must have set-top box, right? See, if set-top box is there, might be your IP stack. IP stack means TCP/IP protocol suite. Okay, it runs on your set-top box or smart TV. It depends on your physical equipment. What you do? See, you have remote. This is your remote you are sitting in. You are sitting on this sofa, right? You are sitting in the sofa. All are neighbors sitting in their sofa. They have their remote control, remote control, remote control, the remote control. You are watching something, Star Sports something, right? So you turned on. So what happens? you are watching, you are watching Discovery Channel or Star Plus something. Now you are changing your television or channel. You are changing your channel. So at the same moment, your set-top box send IGMP join message. Because earlier I was receiving multicast stream for Discovery Channel. That group was 239.1.1.1. When you change your channel, see, I need different. See, this is application perspective things. Now, this set-top box needs to receive Asianet or some other channel, right? See, that channel group is entirely different. So, what? Okay, IGMP join message for Asianet. At the same time, IGMP leave message for Discovery Channel or Star Sports, what you were watching earlier. Same. See, this guy watching Asianet. This guy watching Asianet. See, if you approach unicast routing, if you approach unicast method, the problem is, see, video streams are big packets, right? It's not like your interactive applications. Interactive applications, packet size is always small size. It's not big frame. I mean packets. Video means right? If it is HD, right? So IPTV server or headend needs to create one for your neighbor and another for your next neighbor. See, three different streams or three different packets. What IPTV does or IPTV source headend does, headend creates one stream. See, multicasting. This same comes to like this. See, IGMP. Now, beyond this set-top box, there might be some L2 devices, there might be your some other L1 devices, and finally, there must have a L3 device known as LHR, last hop router, to which receivers are connected. These set-top box are behind this LHR. This device is not visible from our home, but it is there somewhere in service provider. This router is there somewhere. And IPTV, see, you are sitting in Kerala and something Calicut, right? Your IPTV might be in Cochin or Tamil Nadu somewhere. It's so wide. See, now from here you need to transport your multicast streams from this source to each homes, right? It's from satellite signals are coming to IPTV headend or source device. From there, of course, there would be some, you know, uh, the conversion, right? So if it is analog signal to digital, digital to IP packet, that packetization delay, those all kind of things are there. Okay. Finally, those packets would become IP. See, now this is your IG. Now here for those MPLS students, not for enterprise, for those service provider students, see, you might have provided, this is your home, your user's home or office, something, right? See, you are providing connections, right? See, it's your access layer network, something, or T4 network means rural area network, rural area POPs, point of presence. See, this is your point of presence. And also you used Cisco low end series switches or any other vendors low end series routers. And you are not interested to configure multicasting in this area. But you have some L3 hops. From here, it's your core or P2 location something, or its aggregation something. So see, this is your actual layer 3 hop. This router needs to be configured as LHR, last hop router. Actually, this router, connected behind another L3 hop, but you are not ready to configure multicasting in this domain, because in this domain, my devices are low end series devices, and also I don't need to configure multicasting here. What can you do? How could you fulfill it? As usual, you can configure pseudo-wire L2 VPN, right? L2 VPN, then you can forward the traffic to LSN. See, this is already MPLS network. I'm creating pseudo-wire between this proxy last hop device and this device. See, this is your actual LSN. Now packets come to here. See, here also you can configure pseudo-wire if you need to fulfill this requirement. Depends your network. Most of the cases, your access nodes or T4, I mean the low end series devices or rural area devices, you don't configure any uh, any bandwidth consume or any these kind of applications, multicasting, those kind of things. See, you can carry your traffic over pseudo-wire, then you can terminate on your target device. Okay, this is only for those uh, service provider students. It's not it. Okay, so now let me show you some lab. Any question?
No, no, sir.
So now let me show you. So after showing lab, I will come to layer 2 protocol. Mhm. Okay, see, focus on this part. Okay, let's assume this is my end device, means host. This is my LHR, because now we learned only between host and LHR, right? So this is my communication L2, sorry, R2 is one of the receivers and R8 is the LHR to which my R2 is connected, right? Fine. So where is my R2? Okay. So here Cisco iOS devices, first of all, if you configure multicasting, okay, these devices or their iOS code by default supports only unicast routing. First of all, you need to enable multicast routing, IP multicast routing. This is the first responsibility. Enable IP multicast routing. So the moment of creating IP multicast routing, you can check your multicast routing table. Uh, Let me shut this. Moment of configuring IP multi. See, this is your show IP emerald. See, none of the information is there. You just configured IP multicast routing. IP multicast routing. Hmm. So the next command, show run interface Ethernet 0 bar 1. See, I'm just configuring this is pure session lab. Let me remove these unwanted configurations. See, I have configured IP ping sparse mode command. PIM is a protocol. You need to enable it. PIM protocol on necessary interfaces. I come to PIM. PIM is not part of syllabus, but it must be enabled before you enabling IGMP. And if you enable PIM, what happens? If you enable PIM, IGMP, is it complementary? Check it. See, no, IGMP. See, now I just brought up one of the interfaces where PIM has already been configured, right? You just ignore this information, okay? This information you please ignore because I'm getting from here. See, these two informations are by default. See, not these two information, this information. Why I have already shut down this interface? Already shut down, right? It's shut down. Okay, so by default, you get this information. Okay, anyway, I will teach you in detail this IP multicast routing table. Okay, so now you have this information, right? So this 224. Okay, see, you have this information. This IP, yesterday I told you, right? Yesterday I told you this IP 224.0.1.40, something related to RP. When I was teaching you a permanent range. Permanent range, I asked, just remember 39 and 40. Where 40 is the RP, something related to RP. It's a default behavior. See, it's a default behavior, nothing is there. So I have already enabled show IP pin interface. See, one interface is the 0 bar 1. Okay. Show IP interface, show IP interface, Ethernet 0 bar 1. See, you are listening to these groups, okay? Once you enable pin mode. Next information, here it is not getting, show IP, IGMP. See, is it complementary? Yes. If you enable, you will get it automatically, IGMP. No need to explicitly configure IGMP, but the complement package is version 2. It's not version 3, IGMP version 2. Again, explicit IGMP command is not required. If you enable PIN, it comes automatically. Kind of inheritance from PIN. But mode is version 2. They has been inherited from PIN. See, end device. Here I am not going to configure PIN mode because see, it's the end device computer. We don't configure PIN. PIN is a routing protocol, right? Why should I enable? Should you do you enable OSP for BGP your end laptop or end devices? No, right? See, same way. It's not required. But if you're not enabling ping, then you need to enable IGMP manually. IP IGMP version 2. So IGMP, show IP IGMP industry. See, it is the 0 bar 0. See, Here I'm demonstrating or I'm using router as my end device because I don't have computer. I don't have multicast applications. So I need to demonstrate the same step as multicast application is launched. So if you double click, right? If you do double click, where a multicast application is launched. So what I do here to demonstrate the same result, to demonstrate the same result, to demonstrate the same result, what I'm doing, I'm just joining in that group. I'm joining in group IGMP join group. For demonstrating, I'm just using this group. See, source is not relevant. See, version to send report message, unsolicited report message. See, to avoid latency. See, if this device sends solicited report message, this device should wait for next query message. But device hasn't waited. Device hasn't waited for next query message. It has sent unsolicited message because we avoid the latency, right? Else we need to wait next 60 second or 35 second or 30 second, whatever it. Here, it was immediate action, unsolicited report. See what I am sending? Star comma G, star comma G. G means group. Star means any source. Very important terms in multicast routing, star comma G and S comma G. S comma G I'm going to teach you, but star comma G I'm teaching. Star comma G means any source. Star means star indicates any source. But destination, see, this is my multicast group. This is my multicast group. This is my, I'm expecting from any source. This is my IGMP version 2 message. See, query received. It happens periodically. It happens periodically, you know, right? As the last session I explained query part. It happens. See, now IGMP message has been received by R8. It's my LHR. It's my LHR. It's my LHR. What did? What did LHR perform here? What did LHR perform? LHR perform some action when this IGMP join message received. It performs something. Earlier my routing table entry. See, look at my routing table entry. I had only star comma 224.0.1.40. After receiving IGMP join message or IGMP report message from host, my LXR did some modification in my multicast routing table. See, star comma G, star comma G, not S comma G, star comma G, because client requested star comma G. The same information has been replicated in the routing table as well. See, same information has been replicated. See, interface was 0 bar 1. 0 bar 1. The first statement. See, I'm just introducing multicast routing table. I'm introducing multicast routing table. See, when LHR receives or whenever LHR receives IGMP report message based on data, they create entry in their routing table. Next, I'm gonna initiate one more. I'm gonna launch one more application. I'm gonna launch one more application. IP IGMP join group 239 dot. Earlier it was 8.8.8. I'm opening this one. Okay. What happened? See, send. What happened here? Created one more entry. See, created one more entry. Created one more entry. Joining one more. What happened? I'm sending one more IGMP report message. See what I'm saying here? I would like to receive multicast stream, or I'm interested in this multicast group, and source can be any source because I'm marking star. There is no source specific. What is happening here? See, I have one more entry. One more entry. See, this is default one. Leave it. Ignore this part. See, now this is your version 2. Version 2. Version 3, I explained each fields, right? Now I'm see the default, the inherited feature or inherited BGP version is version 2, right? Let me modify version. Let me modify version 2. Let me modify from version 2 to version 3, right? Version 3. The complementary, I mean, the inherited feature is IP IGMP version 3. IP IGMP. Now let me clear first this one. Hmm. Now let me configure IP IGMP version 3. So IP IGMP. So IP IGMP. This version 3. Not showing. Not showing. Anyway, this version 3. Okay, fine. Now show IP. Where IP and root. See, I don't have any. Now let me add something. IP IGMP join message. Here I can do anycast as well, right? Anycast, sorry, not anycast, any source as well I can do. But I'm using, because the theory part I have already explained, so I'm using source specific 8.8.8. See, 8.8.8 source I would like to receive from 8.8.8.8. Now see my query message, sorry, report message. Version 3. See, add source record. See, add source record. I have shown you, right? I have explained. Add source record. Here, see. Add group record. This is your group. Okay, unsolicited. Unsolicited. What happened here? See, okay, I have enabled this, source specific multicast. Assessing IGMP version 3. Might need to configure SSM. Then only it would come source specific multicast, but it is not coming. Usually it comes without configuring SSM. Receive this this will run interface Ethernet 0 by 0. IP, IP, IGMP join group 232.1.1 source. See, add source record. See, you have new entry 232.1.1.1. You see this coming star comma G. So in the SSM session, I will explain detail this part. See, here you just see your IGMP version 3 messages. See, unsolicited report. See, here you have add sources information. And if you add only IGMP, join IGMP, IP, IGMP, join group 239.239.239.239. Okay, what happened here? See, again unsolicited. Unsolicited messages are sending here. Okay.
What is
Now
the
again,
type shown?
which one? This type I explained here, right? That add source, then method. So exclude method,
Okay,
include method, those kind of things I
okay,
explained,
okay.
right? So earlier it was not type 4, right? Earlier see it was type 1.
Type 1.
See, it was type 6. See, it get changed because that theory part. So if you do packet capture, you will get more, because if you do this debug and detailed theory session again packet capture, it will be very confusing. Okay. So now how, or this is version 3. So version 3, version 2, version 1 is not same way, because it doesn't have better layer mechanism. That's only difference from version 2, right? So this communication is happening between your end device and, see, version 3 I will give you more practical session when I'm teaching you SSM. Okay, SSM. Just I need to introduce this version 3. Theory part I won't cover again this theory, but be familiar with these things. But in practical, this here source comma S comma G and star comma G. Anyway, there are two information, star comma G and S comma G here. So now we are covering star comma G here. So let me here IP pin spark node. IP pin sparse node. See here, see S comma G. This is my S comma G. See, specific source and group. See, below any, this first one, this highlighted one is source specific multicast. The second one, star comma G, is any source multicast. See, here. We are sending, this is S comma G, this is star comma G. I have shown these two difference, S comma G, star comma G. Again, see star comma G. Because why only star comma G? Why only star comma G for 239C? I haven't configured. This is any source multicast. See, this is any source multicast. That's why there is no S comma G entry. But we have seen S comma G entry for these two messages because I configured source specific. So this is difference from this node. From tomorrow onwards, I'll be covering from this node. From this node, see, routing part. The routing part is pending. I'll be teaching you coming days from here. See, this session today we are completing. Means LAN session from your end device. Here one more equipment is there, switch, that I will teach you. See, now this part I'm completing. From here, I don't have IGMP message. Between routers, IGMP is not relevant. IGMP is between end device and router. Between routers, PIN protocol. PIN. That is routing protocol. I will teach you that in separate session. Okay. Now, second. Any question? Okay. If no questions, then
Yeah, no
let's
questions.
move to. Okay. Let's move to layer 2 protocol, IGMP. IGMP is actually Cisco proprietary product. So in big multi-vendor network, it's not good decision. CGMP. It's not right decision. Why? Cisco specific protocol or it's a Cisco proprietary mechanism or protocol. So if you have some other vendors in your network, Huawei, sorry, any Juniper, Nokia, yeah, any device, those don't support. Now come to CGMP. Yeah. Okay, CGMP. Cisco Group Management Protocol. Cisco Group Management Protocol, L2 protocol. IGMP, L3 protocol. Right? Why CGMP? I explained, right? I already explained. CGMP, see, your multicast streams are coming from upstream to downstream. This is your L2 switch, right? You have bunch of devices behind switch, right? You have bunch of end devices, right? These two devices are interested in this multicast stream. These two devices are not interested, but lack of switch capability or due to their legacy behavior, right? This bump traffics flooded. But I need to protect this flooding, this part. I need to protect because I don't need to uh, consume this bandwidth. It's unwanted traffic, right? So how to protect this one? So to deal with CGMP, we have two important concept. Concept means, yeah, two important fields in CGMP. One is GDA. GDA means group destination address. Then USA. Unicast source address. Unicast source address. These two terms are key roles in CGMP protocol. These two terms. Okay. What happened first? There, I'm just segregating these CGMP operation in two phases. Phase one, between LHR and switch. See, your end devices are not relevant. The first phase that happens between LHR and my switch. See, when CGMP enabled on a router, I need to enable here, right? CGMP. See, it will start sending CGMP messages. See, it will start sending CGMP messages. When LXR sends CGMP messages, these two fields are there, GDA and Unicast. See, GDA set to 0 and USA set to their own MAC. On MAC means their own interface MAC. On interface MAC. When this message is received by switch knows, yes, router is connected on Ethernet 0x0 interface. When this message is received, switch recognize Router is connected on interface Ethernet 0/0. That part is completed. That part is completed. Okay. Finding out routers, see, completed. So in this way, routers are determined or find out by switches, right? Let me have a look. Okay. So phase one is complete. See, the first message is sent, then switch knows there is a multicast router on that interface, right? On that interface. Means on that interface means where CGMP is received. CGMP is received here. So here multicast router presence is there. Then phase two. Now let me draw and device. And assume this is A. Their MAC is B. Their MAC is C. Then group MAC is there. Yesterday I explained, right? How group address or group MAC address is calculated. There is a standard way, right? So group MAC address is there. Let's assume group MAC is A, B, C. Okay. Membership report. It comes from PCA. Assume PCA. What happens here? 0/2, 0/2. Switch learns the traditional switch functions. Learn source MAC address and publish in their MAC address table. See Ethernet 0/1 MAC address A. This is their unicast MAC address. Method dynamic, right? Then if they look at destination MAC address, see IGMP report message, the destination MAC address is group MAC address, which is multicast MAC address. It is part of bump traffic. It's bump traffic. So it is flooded by switch. Finally, it is received by router as well as B and C. Okay. Now router received IGMP report message. Now router knows, okay, MAC address A would like to receive multicast streams. Multicast streams in MAC address ABC. See, actually, router A announces L3 address as well, right? L3 is not relevant in this L2 switch. See, router notices their L2 MAC as well. For routers function, they would use IGMP or group IP address, but they would examine L2 address as well at the same time. So group address is ABC. Now router is gonna construct CGMP join message. See, CGMP join message. The CGMP join message, see, router knows group MAC address, right? Group MAC address router knows. So JDA ABC group address and USAA means this unicast source interested in this layer 2 multicast string, in this layer 2 multicast group, or in this layer 2 multicast address or stream group, you can call anything. Now this CGMP message comes here. See, now switch has already learned this source MAC address. Now they would mark one more entry. Okay, this device would like to receive multicast stream in MAC ABC. See, MAC address table or MAC address entry or entry in MAC address table has been expanded. Some more additional information has been added. Earlier, it was only unique or unicast information. After getting CGMP join message, switch added few more information to map their multicast layer 2 addresses. Now what happens? Switch B does the same thing, right? Same thing. Here, switch B, sorry, PCB 0/2 B dynamic. When report message goes or comes from the device, then it goes to LHR. LHR checks L2 MAC address. Then based on L2 MAC address, LHR constructs CGMP message. Now CGMP message JDA same ABC, but USA is different B. See, now it comes. See here what they mark ABC. Now let's assume, so these two devices reported. These two devices reported, we are interested in group ABC. ABC means layer 2 address and corresponding IP address. We are interested. Now multicast stream is coming. It is coming to switch, but switch doesn't do their traditional behavior. If switch follows the traditional behavior, it would have been advertised or it would have been flooded throughout VLAN. So this is your communication. See, switch C, sorry, device C is receiving. It would have been flooded throughout VLAN. But I configured CGMP, so switch consults their destination MAC address. So destination MAC address is, see the multicast streams, destination MAC address is ABC, right? ABC is the group address. So only these two interfaces, to which interested parties are connected. Okay, so interested parties are present behind these two interfaces. See, I'm flooding here and here. Here I am not flooding, but in my MAC address table, this information is there. How did switch build this entry? By the help of router. Router constructs a CGMP message, join message, and then it sends to switch. See, this is CGMP. So if you send IGMP leave message, switch look at IGMP leave message, then picks layer 2 information, construct CGMP message, leave message instead of join message, constructs CGMP leave message, then informs switch. Once CGMP leave message, see, eliminated. Now next multicast stream, it would be forwarded through 0/2, or it would be forwarded only through 0/2 because already received CGMP leave message, and based on CGMP leave message, switch deleted that entry. So this is how CGMP works. Any question?
No, sir.
Okay. CGMP Cisco proprietary. So if your network is multi-vendor network, and if you have multiple vendors switches in your LAN network, then CGMP is not right choice. You have IGMP snooping options. IGMP snooping. What IGMP snooping does? Actually, snooping, what it is doing is, see, it is intercepting your IGMP packets. Okay, switch is actually intercepting your IGMP packets and do deep examination. See, intercepting packets, do deep examination. Does switch do like this? No, by default, switch doesn't do like this, right? So just look at layer 2, switch doesn't intercept and switch doesn't do deep examination on packet. Based on layer 2 header, it is flooded. But here what switch does? Intercepts IGMP packets, do deep packet examination. For doing deep packet examination, IGMP message is forwarded to CPU. For doing this deep examination, IGMP packets are forwarded to CPU and CPU does that deep examination. Okay. Now, IGMP is open standard first of all. Then IGMP snooping. See, in in base switch, but I'm not sure because nowadays I've been working in different domains, so I'm not sure in enterprise network. Low catalyst switches. It's present or not, I'm not sure. But in earlier days, we had some problem in catalyst switches. See, those switches were coming without L3 aware ASICs. ASIC, you know, right? Without L3 aware ASICs. Those switches didn't have L3 aware ASICs. So it was the problem. So in those, but I'm not sure nowadays. There might be your UL devices, and there might be some low and serious devices from still from Cisco. Anyway, IGMP snooping without L3 aware ASIC. Here there was some problem. See, in those days we had some problem. The problem is you have switch, you have, I'm just CPU is there, right? Then switch, this is your interface. This is your backplane. Backplane, let me draw in different term. This is CPU. This is my switch. Then I have backplane, right? Backplane is actually, see, backplane is actually interface to this full mesh backplane is there, right? Full mesh backplane like this, right? See, interface to interface. Inside traveling from one interface to another interface, you need path, backplane path, right? And you have CPU is also connected to the same bus system, right? CPU is there. Okay. Now, what happens? IGMP packets, right? IGMP packet, it comes from this device. Here your device comes. See, here switch intercepting. Switch is intercepting your packet. See, forwarded to CPU. CPU does some deep examination, and based on your IGP information, the IGP information, what are the informations are there? See, if switch concerns their L2 header, right? If switch look at their IGMPs, L2 header, they can easily get source unicast MAC. Destination MAC is, see, destination MAC is group address. See, if they just examine your L2 header, source and destination field, they can easily understand this user is interested in this particular group. Just they need to look at your L2 header. After looking this, see this communication, I am just calling one interface is there between your physical interfaces and CPU, right? Now, see this switch, MAC is A and group MAC is ABC. See the switch is marking, this is E0 bar 1, right? E0 bar 1, A, then group address ABC. This is unicast, this is multicast. See, one more address, sorry, one more interface would be mapped here. This is your interface, virtual interface in between CPU and your physical interface, right? Interface. See, now this multicast address has been mapped with your physical interface, which is Ethernet 0 bar 1, and also mapped with your inside virtual interface. This is the path towards CPU. This is, I'm just using INT interface word. Okay. Now you are getting huge amount of multicast stream. bulk multicast stream is coming. Bulk multicast stream. See, multicast stream destination address is ABC. Now switch is not dummy switch. Switch is IGMP snooping capable switch. Of course, they would look at their L2 header. Then based on L2 header, say they would consult their MAC address table. The MAC address table, if destination MAC address is ABC, sent through E0 bar 1 as well as interface. See, this packet would be forwarded through this interface as well as one copy to CPU. See, this bulk amount traffic is hitting CPU. Bulk amount of traffic hitting your CPU. So it was the problem years ago when we didn't have L3 aware S6. But there might be some devices today, but I'm not sure the series of devices, I'm not sure. But if you have without L3 aware S6, this problem would be okay. If you have L3 aware S6, then see when they create entry in their MAC address table, this information there won't be. This information won't be present. See, now if you receive multicast stream, it would be getting forwarded over only Ethernet 0 bar 1 because it is L3 aware ASIC switches. L3 aware ASIC switches. Let me show you lab. I'm not sure this is actually virtual device. I'm a bit doubt on accuracy, but I can show you something here if I'm right. See, in the IGMP snooping, you have some, see, in CGMP, how did switch recognize routers or how did switch now? Router is connected on this interface after receiving IGMP join message, right? Here, do you have any message between router and switch? No, there is no message. But you need some option, or you must have some method to identify or to find out routers or to find out your LHR. See, how is it? What we can do? See here what we do. See, switches relies on some special type of packets. Okay, switches relies on special type of packets such as IGMP general query message. See, IGMP, IGMP. See, if your switch receives, if it is LHR, see, if switch receives IGMP join or IGMP query message, see, now switch knows yes, router is connected because query message is sent by routers, right? So if it is received, then okay. Then some OSPF messages or HSRP messages. See, not only IGMP join message or PIM message, then HSRP message. HSRP is L3 device, right? Then PIM or OSPF, like that, or multicast aware, something like that. So switches relies on this packet. If you receive any one of these packet, then okay, router knows, okay, E0 bar 0 towards router. So this is the mechanism in IGMP snooping. In CGMP, router itself generates CGMP join message, so router switches can easily find out their LHR or their L3 hop. But here there is no operation or communication between LHR and my L2 switch. The switch itself intercepts my IGMP packets and switch itself does some examination. There is no role for my LHR. Switch itself does. So, but switch needs to find routers. So switch relies on this packet. If switch receives any one of these packets, okay, switch knows that router is connected on this particular interface. Clear? It's easy task. Okay. So now this is this is different ways. Is there any I can show you first how switches find out. How does switch find out routers? First step. First, we need to enable IP, IGNP, snoping command. We need to enable, right? After that, it's a global command, not per interface command. Debug IP, IGNP, snoping, okay. Let R11, right? IP pin stash now. See, received IGMP query message router. See, is router port on VLAN 1 port Ethernet 0/0. How did switch do it? See, just received IGMP. There is no any special message in between LSR and switch. Once switch relies on those messages. I explained SSRP, PIN, or IGMP join message. So in this case, switch received IGMP join message. Switch found router interface Ethernet 0/0. So IP, IGMP, snoping. See, done. Next, debug IP, IGMP, debug IP, IGMP, snooping. Okay, let it be that. Might be lengthy output. Okay. See, this is my sender. Actually, 11. I'm demonstrating R11 as my source. Okay, not LHR. Okay, not LHR. After some time, I will delete that command. I would just wanted. So I just wanted to show you how our routers are found in IGMP snooping. Okay. So now this is R3. This is switch. Let me show you again. AP IGMP join group 239.1.1.1. See, forwarding a report to router ports. See, switch has intercepted my message and they picked necessary information. Show IP, IGMP, membership, or show IP, IGMP. Nothing, it's not working. IGMP. Groups also now groups. And then it's the other one. Show IP, ICMP, membership is strategic, smoking. Smoking is enabled. Okay, so see, if I receive multicast packets with destination this particular MAC, right? This is but I will be sending out Ethernet one by one. See, again, if switch 4 sends, see, switch 4 sends. Now let me do you one thing. Let me do you one thing. See, this is my standard. Let me check first unicast reachability 198.168.10.3. Yes, I have, right? And ping, ping 239.1.1.1. Yes, okay, working. Now I can show you something. See, it's same broadcast domain. These three hosts are in same broadcast domain, right? See, I'm getting response only from 3. I'm getting response only from 3. It's my expected behavior because it's only receiving. But here, what I'm going to show you, see, repeat option is repeat 10. Okay. R4. I'm sending total 105 packets. Previously, I sent 5 packets. Now I'm sending 100 more packets. So total 105 count. Let me check here. See, are you getting any packets? These are your, the program is, okay, let me assume debug IP package. See, are you getting any package? No. Let me configure IP as well. IP address 198.168.10.4. Why? R4. These are different packets. See, R3 is getting package. Debug IP package. See, getting destination package. See, you can see here somewhere. I can show you one packet here first, 239.1.1.1, first line. After that, again, it is there 133.1.1.1. See, I'm getting packets anyway. 230, this is multicast frames. See, this is my multicast frames. See, multicast frames. I'm getting on R3, but am I getting on R4? No. See, my switch is not dummy. My switch is not dummy. I have configured IGMP snooping. I have configured IGMP snooping. Right? So even if I disable IGMP snooping, I don't know, but let me try. Yeah, IP, IGMP. But it is no. See, this is again R4. See, R4 received. I disabled R4. Okay, see R4 received. Earlier R4 was not receiving because my switch was not dummy. Switch was not flooding throughout VLAN. Switch was just switching packets. Switch was switching packets on correct interfaces. Or correct interfaces means the receiver, only correct receivers interfaces, right? Only through the correct receiver, the receiver's interface is Ethernet 0/1. So switch was just switching packets from Ethernet 0/0 to Ethernet 0/1. It was not being flooded. It was switching to the correct interface. The moment I disabled IGMP snooping, switch started flooding. See, switch started flooding throughout VLAN. Started 4. If you configure 5, 5 would also receive. Because switch is a dummy or switch behaves as their traditional features. There is no IGMP capable or multicast capable because I disabled that feature. Now switch is not switching through correct interface. Earlier it was switching through correct interface. Now it is getting flooded. Okay, so this is our multicast LAN section. IGMP, CGMP, IGMP snooping. Any question? Any question? Hello? Hello?
If one of the client is sending leave message, the switch will decide not to send the packet to that particular one, right?
Yeah, they are doing some examination, right? Switch is doing examination. Here, this router doesn't have any role.
Okay.
Router doesn't have any role. Switch itself does the basic jobs.
Okay.
Because this is what I said. Packets are forwarded to CPU for deep examination. If they do deep examination, they can easily segregate, right? Whether it is a report, leave message, whatever it is. Anything? Any other questions? Clear, right? Who asked? Aravind, right?
Yeah,
Aravind, clear, right?
Yeah, it's clear.
Anyone? If this part is clear, then WAN part is easy. Because actually multicast means it's a tree. See, tree means the tree is established from LHR. Now, tree we started because the first step we have already completed. First step we have already completed. The tree structure, it's not like unicast routing. We need to build tree between source and destination. For building this tree, we use IGMP protocol, then PIN protocol, and one more concept is there, RP. So in the routing class, I will explain that one. See, if this part is clear, then WAN part is easy. Okay, so if no more questions, then we can wrap up today's session. Okay, let's connect tomorrow. Okay, guys, bye. Good night.